So the question here that we're going to try to work through is if you had two people that were heterozygous for polydactyly and they get married and they want to know what are their chances of having a child with polydactyly, or in this case having the normal number of fingers or toes. So this is the condition here called polydactyly. So you can see this person here actually has 6 fingers. So it has an extra digit. It is a genetically inherited condition. And so what you do, what they give you here is you draw your Punnett square, okay? And they give you what the parents are. So we know that the parents are heterozygous, which means they have one copy of the big P and one copy of the little p. And so what you want to do with your Punnett square is, once again, as I've been mentioning before, the Punnett square shows you the chances of the different events happening. So if these people are both the same, if they were the same genetically for this condition and they went through meiosis, what kind of sperm and eggs could they make? And so what you would get is you would get, like, let's say this is the dad, but again, it doesn't matter if dad's here, mom's here, it doesn't matter. But this shows you the different kinds of gametes or sex cells they could make. They could make a sperm or egg that had a big P in it, or they could make a sperm or egg that had the little p in it. And it turns out, since they're the same, heterozygous, both parents, you have the same thing down here. So what you would find then when you cross that Punnett square is you get a homozygous dominant for every 2 heterozygous for every 1 that is homozygous recessive. So that gives you your chances. Now, you might be tempted to look here and say, oh, well, all of these people here would have the normal condition. But what you have to realize with polydactyly is that since this is a dominant trait, that means having one copy of this gene gives you this condition. So actually what you're interested in is this one down here if you want to know the number or the chances of having a normal child, because this would be the one you look for here, because the homozygous recessive is the normal condition. So 1/4 or 25% chance of having a child with the normal number of fingers and toes. Since most people have the correct number of fingers and toes, in other words, most of us are born with 5 fingers on each hand and 5 toes on each foot. This is also a good point to point out that people often confuse dominant and recessive for how common something is. So people think, well, we talked about like cystic fibrosis or that kind of thing, and that's a recessive trait. So they get in their heads that things that are recessive are less common. But in this particular case, it turns out that what's less common is this dominant allele. But if you get a copy of it, you end up having extra fingers or toes. So the more common allele out amongst the population is actually the recessive one. So once again, this is polydactyly, and since it's a dominant trait, these 3 here would actually end up with what you call polydactyly, and this would be the same as how you would work a problem, for example, for Huntington's disease. So if you had 2 people that were heterozygous for Huntington's disease, these 3 out of 4, since Huntington's disease is also dominant, these 3 out of 4 would actually have the ability would develop Huntington's disease, and this is the percentage here. This 1/4 in that square represents those that would not.